So here we are still in 2-1 day 1, and now that you've taken the notes, I want to go through a few examples of how you're going to use the notes that you took. In example 1 here, you see it says to describe the transformations of the graph for each equation compared to the parent function f of x equals x squared. So make sure anytime we ask you to describe the transformation, you know what the parent function is. And in this chapter, since we're talking about quadratics, you're talking about compared to x squared. Okay, so when I look at number 1, g of x equals negative 1/2 times x plus 2 squared, I actually see 3 things going on. Whenever I describe transformations, I'm always going to look for the pluses and minuses first, and in this case, I see an x plus 2 inside parentheses. You'll recall from the notes section that anytime there's something grouped with the x, it's going to shift it horizontally or left and right, but it's the opposite of what you would think, because technically this is x minus h squared. So h is technically a negative 2. So this plus 2 is actually going to shift the graph or translate the graph left 2. And again, if we're shifting left, right, up, and down, that's called a translation. Okay, so the next thing I see is this a value, the negative 1/2. And I actually break that down into 2 pieces. First, I look to see if a is positive or negative. And that's going to tell me the direction of the parabola. Since it's negative, it's going to flip it upside down or open down. What that means is if I was to sketch a graph, it would be an upside down parabola like this. And finally, the 1/2 is going to stretch or shrink it because it's being multiplied by 1/2. Now, because it's outside of the grouping symbol, so it's not affecting the x, that means it's affecting the y values, which means that it's vertically affecting the graph. And anytime it's outside the parentheses and affecting it vertically, it does exactly what you would think. So since 1/2 is between 0 and 1, it's actually going to be a vertical compression of 1/2. Okay, and on the next slide, I'll show you the graph of that as well. Okay, so when I look at number 2, again, I see 3 things going on. This time, I see the 2 in front, the x minus 1 in parentheses squared, and then finally the minus 3 on the end. So if I look at the pluses and minuses, first I'm going to look at the x minus 1. Again, the minus 1 is grouped with the x, so it shifts it left or right, but the opposite of what you would think. So it'd be a horizontal translation, but this time to the right one. The minus 3, because it's outside the grouping symbol, is going to translate it vertically, so up and down, and as you would think. So the minus 3 is actually going to move the graph down 3. And last but not least, this time, the a value in front is positive, so it's going to open up. You don't have to write that because we default to that, but it's going to open up like this. And finally, the 2 is going to be a vertical stretch since it's bigger than 1 by a factor of 2. Okay, so on the next slide, I'm just going to quickly show you what those graphs would look like. You can see that it reinforces what we just said, but in letter A, we said that it's going to go to left, open downward, and vertically compress. Okay, well, I get the question a lot of what moves to left. And again, we're talking about the parent function. The parent function is f of x equals x squared. So we need to know that the original vertex is at 0, 0. So typically when I graph these, I know that this means that the vertex, because it goes to left, it would be at negative 2. It didn't shift up and down at all, or negative 2, 0. So we plot the vertex first. And then, to be honest, the easiest way to probably graph the rest of the parabola is just to make a table. You could plug in like negative 1 and 0. So if I have x is negative 1 and 0, I find the y values. So if I plug in negative 1 up here, I get negative 1 plus 2 is 1. 1 squared is 1 times negative 1/2 is negative 1/2. If I plug in 0, I get 0 plus 2 is 2. 2 squared is 4. 4 times negative 1/2 is negative 2. What that means is I could plot a point at negative 1, negative 1/2, and because we know parabolas are symmetric, I would just reflect that across. And then I'd plug a point in at 0, negative 2, and again, because they're symmetric, I reflect it. So I would encourage you just to make the little t-table for the 2 points next to the vertex, or the 2 x values next to the vertex, and it allows you to quickly reflect them and graph it. Okay, and then you can see the same thing on the right-hand side. We shifted it 1 right, 3 down, which means the vertex is at 1, -3. And again, it's a vertical stretch, so it's steeper. You could make that t-chart again. Okay, so I want you to try now. I want you to describe the transformations of the parent function of f of x equals x squared, and then I want you to practice sketching the graph of the function. So pause the video, try both number 1 and 2, and then once you're done, play the video again to see how you did. So here are your answers. For number 1, we had the x plus 2 in parentheses, so that's 2 left. And then we just had the negative outside, which means it opens down. When I go to graph it, it means I take the point that was at 0, 0, I go 2 left and shift down 2, which means your vertex should be at -2, 0. Again, I showed my t-chart over here. If I plugged in -1 for x, I got a -1 for y, so I plotted a point at -1, 1 and reflected it. And then if I plugged in 0 for x, I got -4 and I reflected it. So that's how I got those 5 points for my parabola. So there was no vertical stretch or shrink in this case. And number 2, when I look at this one, again, the x minus 1 makes it go right 1. The plus 2 has it go up 2. Okay, so from 0, 0, I go right 1, up 2, which means your vertex should have been at 1, 2. Again, I can pick the next 2 x values, 2 and 3, plug them in. I get the point 2, 3, and reflected it. And then I got the point, when I plugged in 3, I got 6. So at 3, I got 6, and I reflected it. So it's not a great parabola, but you can see that I had the general idea. All right, now, before we go, we want to try one more type of problem, and that is finding the key features of a quadratic function, graphing it, but now we're going to add in vertex, axis of symmetry, max, min, domain, and range, stuff we've looked at last chapter. Okay, so anytime I'm asked to do this, I go through what we just did, and that is I always describe the transformations, even though it doesn't ask me specifically to do that. So I see the x minus 3, and right away I say that's going to go 3 right. And then I see the plus 4, which means it's going to go up 4. The a value is positive, so it's going to open up. And because it's a 2 outside there, it's going to be a vertical stretch by 2. Okay, so again, before I even graph it, and I could graph it here, but I would take the point that would have been at 0, 0, and I'm going to go 3 to the right and up 4, which means that that vertex is at 3, 4. Okay, if I want to continue graphing it, I'm going to make my xy table, and I'm going to test the points 4 and 5. Plug 4 back in, I get 4 minus 1, or 4 minus 3 is 1. 1 squared is 1, times 2 is 2, plus 4 is 6. So it is important that you do the correct order of operations. You obviously can always type it into a calculator too, but you'll see that I can do it pretty quickly if I follow the right order. So then I plug in 5. 5 minus 2 is 2. 2 squared is 4. 4 times 2 is 8. And then 8 plus 4 is going to be 12. Okay, so I have a point at 4, 6. Again, I'm going to reflect it. So that means I also have a point at 2, 6. But then I'm also going to have a point at 5, 12, which means I also have a point at 1, 12. Okay, now, when I'm doing that reflection, remember I mentioned before, we're reflecting across the axis of symmetry, and that's the vertical line that cuts right through the vertex. Okay, so this vertical line is x equals whatever that h value is. So x equals 3. So it's not a coincidence, but these two numbers will always match. Okay, maximum or minimum, obviously that's going to depend on if your parabola is open up or down. Because it's open up, we're talking about a minimum value here. And that's the minimum height. So that's going to be the y value of that vertex, which is 4. Domain goes back to chapter 1. Domain of a parabola, it covers everything from left to right because it has these arrows. It keeps going left and right forever. So it's going to be from negative infinity to infinity. And finally, my range, that's my y values. The smallest y value it has is that 4. We already said that's a minimum. It is the point on the graph, so I have to put my bracket next to it instead of the parenthesis. And then finally, the graph does in fact go up forever, so my highest y value would be infinity. It goes on forever. All right, I want you to try one of these, and then that will be it for today. So pause the video as we did before, and I want you to, again, identify the vertex, axis of symmetry, max or min, domain, and range. If you want to graph it to help you visualize it, that would be great. But pause the video, take your time, then come back and check it. So here's what you should have had. You should have seen that the x plus 4 makes it go left 4, the minus 5 makes it go down 5. The a value is a negative 1, so it just opens down. There's no stretch or shrink, which means my vertex is at negative 4, 5. The axis of symmetry then is at x equals negative 4. So then when I made my xy table, I plugged in negative 3, negative 2, and I was able to reflect across that axis of symmetry. This time it's a maximum value because the highest point is the y value of that vertex, which is negative 5. Domain is still negative infinity to infinity, and that's going to be the case for all parabolas. And finally, this time, be careful with the range. Remember, your interval notation always has to go smallest to biggest. So since this graph goes down forever because it's an upside down parabola, your negative infinity has to go first. And then finally, it stops at 5. That's the highest value. So make sure you put a bracket. So if you had that range backwards, make sure you correct that. Okay, that's all for today. So go ahead and start working on your homework. And tomorrow we will move on to some more stuff working with vertex form. Thanks.